here is just one example. Let's say I'm going to sketch just to explain exactly the meaning of this. Let's say you have here the y-axis, okay, and we have the x-axis, and here is 0 for x and y. Let's suppose you guys have this curve. This is the curve. This is my pyramid curve. I'm going to call it C. And at t equal to 0, for example, this is the initial point. At t equal to 0, for example, initial point, the coordinate of this point is what we call x0 because t equal to 0, and the corresponding y here is here. This is a y0. So you notice here x and y represent the coordinate of this point at the time t equal to 0. So it means when the value of t changes, the value of x and y gonna change too. Okay, let's suppose here. Hello, your mic, please. Let's suppose here your t is here. Now, when t equal to, let's say, 10, okay, you will get the position here. Now, t is equal to 10, and at t equal to 10, you will guys get here x at 10. So it means x1, the x coordinate, and the y coordinate going to be here. Y10 going to be, for example, here. This is y10. So you can see here, x and y depends on t in 2 dimensions. So this is, what we mean by a pyramid curve. It is a set of equations depending on a parameter, and x, y represents the position on the curve of C. And sometimes, you guys can get a range for the values of t. If the range is given, the first value here, a, will be the the initial point. In my case here, if you look at the curve, my initial point is when t equal to 0. It means my a here is 0. And if you want to find, the corresponding point when t equal to 0, you have to use the equations here. In this equation, you replace t by 0, so you guys will get here the first coordinate. So we just substitute t by 0, by a, sorry. Okay, when t equal to a, you will get the first coordinate. That's why I call it f of a. This is the x when t equal to a. And for y, you will get this value when t equal to a. And this represents, the coordinates of the initial point, because when t equal to a, you guys use the smallest value of a, means the smallest endpoint of this interval. When t equal to b, you will get the largest endpoint, and the largest endpoint gonna give you the terminal point on the curve. So here we just substitute t by b, and then we'll get the terminal point. For some example now, the range is not given and will be defined by taking the intersection between the domain of f and the domain of g, and you guys have already seen in 1500 how to find the domain of a function. Okay, and here are 2 examples. In the first example, we have a range for the values of t. X is defined by f of t is my equation here, and this is my g of t, and t should be between 0 and 2. That's exactly this case. In this case, my t equal to a, my a is 0, and my b is equal to 2. If you want to get the coordinate of the first point, the initial point, I have to set t equal to 0. And when t equal to 0, you substitute in these two equations in order to get the coordinates of the first point of the initial point. When t equal to 0, you replace t by 0 and you will get the x coordinate and the y coordinate of the point. When t equal to 2, you will get the terminal point. So you have to substitute here t by 2 and you will get the terminal point. In the second example, there is no restriction for t. T belongs to the set of all real numbers. It means you can take any number here. There is no, in this case, we don't have initial point in this case because, you know, t belongs to R. We don't have initial point. The terminal point also does not exist. Keep it in mind. You know, so it means here, you know, if the question asks, sometimes give you a range for t, you have to take into account, you know, in your work the range. If t does not give you the range, it means t could be any number. Okay. All right. So now we'll see how to calculate the derivative. So back to our previous slide. So for example, you guys can see here, if for some reason I want to calculate the derivative of y with respect to x, based on what you did in 1500, your y is always equal to a function of x. That's why in this case, it's going to be easy to get the derivative of y respect to x. Okay, so here we don't know exactly how y depends on x. That's why we don't know exactly, we cannot calculate directly, you know, the derivative of y with respect to x. Okay, so based on what you did in 1500, for example, oops. All right. So based on what you did in 1500, dy by dx means the derivative of y with respect to x. This is exactly equal to f dash or f prime, the same thing. Okay, so this is, you know, in the case of a function based on what we did 1500, but here we don't have a function. Okay, so we have two equations. So since we don't know how y depend on x, we can use this formula. We have to find another way to get the derivative of y with respect to x, and it's given right here by this, you know, by this remark. To calculate dy by dx, you have to differentiate y separately and x separately, and both with respect to t. Okay, because at the beginning you guys want to get, as I said, you know, dy by dx. Okay, so since you don't know how y depends on x, so that's why what we can do here, knowing how y and x depend on t, so it means you have to introduce t up and down. So when you introduce up, t up, you will get dy. So it means the derivative of y with respect to t. You divide by dt. So since you divide by dt on the top, you have to divide by dt, you know, at the bottom too. So you will get here dx by dt. And this is going to give us exactly this formula. So provided that now the denominator here is not 0, because you cannot divide it by 0. That's why I add this condition here. And this notation dy by dt is in the numerator. Since we know how y depends on t, dy by dt is just f dash, means the derivative of f with respect to t, and f is just y. And derivative of g with respect to t, keep in mind g represent x. So it means this writing is similar to this. It is the same thing, but different notation. Okay, so dy by dx here is your f dash, and dx by dt is your g dash. And this formula is obtained from what I explained before. We divide up and down by dt, and doing so, you guys will not change the initial value of dy by dx because you divide by the same thing. Okay, and you guys have to keep in mind this formula, how to calculate dy over dx. Okay, any question? All good? All right. So next we'll see how to identify where the curve C has a horizontal tangent. Okay, and a horizontal tangent is just a line, like y equal to m times x plus b. As you know, this is equation of a line. But for a horizontal tangent, the m should be equal to, based on what you did in 1500.
0.
What is the slope here?
0.
The slope is given by the derivative, right?
Yes.
So m is equal to dy
By dx.
by dx. So you did it in 1500. Anytime you guys want to find the slope of a tangent line, you have to differentiate your function. So you differentiate the dependent variable with respect to the independent variable. So independent variable is x and the dependent variable is y. So y depends on x. You differentiate y with respect to x at some point where you want to get the tangent. If you want to get the tangent to 1x equal to 2, so you have to calculate the derivative here and replace x by 2. Okay? Now, we're going to use what we learned, in 1500 in order to identify the point on C. C is the curve where the tangent is horizontal. And since the tangent is a line, you guys know one characteristic of a horizontal line. Its slope is equal to 0, right?
Yeah.
Yeah. So any horizontal line has its slope equal to 0, and this is the slope of your line. If the slope is 0, so the line becomes y equal to b, which is a constant, and it's going to be a horizontal line. And this is exactly what we're going to use this information in order to identify the A where the tangent is horizontal. So since this is equal to 0, we're looking for now to be equal to 0. So you can say here, m equal to 0 if dy by dx is equal to 0, right?
Yeah.
But based on what we did in the previous slide, dy by dx is equal to, so this means
dy by
dy, your mic please, dy by dt
Yeah.
is the numerator
By
over
dx by
dx by dt equal to 0, right?
Yeah.
And the only way to get this equal to 0 is the numerator is equal to 0 and the denominator is not 0, right?
Yes.
So this means dy dt is 0 and dx dt is not 0. In this case, you guys will get 0 over a number which is not 0. And you guys can see this is exactly what I represent here. Okay, so from now you don't need to do all this proof. What I did here, I just did it in order to show you where this formula or where these two conditions, came from. Okay, so these two formulas, these two conditions are satisfied where the tangent is horizontal, because this dy dt is 0, dx dt not 0. When you take the ratio, so you will get 0. And when it's 0, it means the slope at this point A gonna be 0. And when the slope is 0, it means the tangent is horizontal. And you guys have to keep in mind these two conditions. It's gonna help you when you guys wanna find the point where the tangent is horizontal. Is it okay? So you don't need to prove it again. I just did it in order to show you why we need these two conditions. Any question?
So what will happen if dx by dt is equals to 0?
Yeah, so good question now. So we'll see it in the next step. Because it's possible at some A to get both of them equal to 0. And as you know, when you have 0 over 0, you will not be able to conclude. Okay? So we'll see in this case what we have to do. Okay? So if you, as your friend said, you know, both of them are equal to 0, so numerator here going to be 0, denominator going to be 0. So we cannot say the slope is 0 because you have 0 over 0. So it means, you know, you cannot calculate the slope at this point. In this case, what you have to do is to approximate it. Okay? So since we don't know how to calculate this, you know, the slope at A because we have 0 over 0. In this case, what we have to do is to approximate the slope. And this is my slope here. And how to approximate it? Because I want to find the slope at A. But at A, I got 0 over 0. What I have to do in this case, since I cannot calculate it at A, I'm going to calculate what I'm close enough to A. And calculating when I'm close enough to A is the meaning of calculating the limit when T is approaching to A. And this is exactly what you guys have to do. And it's presented here in the next slide. Next point. If now, as your friend said, you know, dy dt is 0 and dx dt is 0, you cannot conclude, you have to approximate. And approximating means I'm going to calculate here the slope, because this is the slope, dy dx, when t is close to A, not equal to A, because when it's equal to A, you get 0 over 0. Now, you let your t really close to A, and you will see what you know the limit gonna be. If the limit returns you 0, it means your slope is approximately equal to 0. In that case, you have a horizontal tangent too. Okay? And keep in mind, you have to calculate this limit if and only if you guys have these two situations. If you have these two conditions, it means there is no possibility to conclude. And in that case, you need to calculate or to approximate the slope by using limit. And when the approximation returns you 0, you still have a horizontal tangent, because the approximation returns you 0. This limit means the slope is almost equal to 0. If the slope is almost equal to 0, so we'll take it as 0 and then conclude we have a horizontal tangent because the slope is close enough to 0. Is it okay? All right. So next we'll see now the conditions that we have to verify in order to get a vertical tangent. And you guys know what is the slope of a vertical line? What is the slope of a vertical line? You remember?
0.
No?
Infinity.
Exactly. When
It's
you
not
have vertical
defined.
line x equal to 9, for example, so because the slope is infinity. So that's exactly what we want here. Just keep in mind. So to get m equal to infinity, now my slope, m equal to infinity, this is my slope that I used before. M equal to infinity means dy by dt, by dx, sorry, because this is my slope, is equal to infinity, right? And so this means I'm gonna substitute, this by its formula. So it means dy by dt, okay, over dx by dt is also infinity, because this is exactly the formula for the slope. And what are the conditions in order to get infinity here? In order to get infinity,
dx by dt should be 0.
so dx by dt should be 0. And that's the denominator. So the denominator should be 0. And while the numerator is not 0, dy by dt not 0. So you guys can see here, we see the condition that we mentioned for horizontal tangent. You see, it's not exactly the same thing. For horizontal tangent, the numerator dy dt should be 0, denominator not equal to 0. For vertical tangents, the denominator should be 0 and the denominator not equal to 0. And in that case, you guys will get a slope which is equal to infinity, and it means your line is vertical line. Okay, and this is exactly what is given by C. And you guys can see this is a proof, and you don't need to write it again when you want to apply it. What you have to keep in mind is the dy dt not equal to 0 and dx dt equal to 0. And don't mix up the two, formulas or the two situations, horizontal and tangent. If you do so, you will be penalized, you will not get full mark. If you guys looking for horizontal tangent and use the formula or the condition for vertical tangent, it means you don't know exactly the difference between horizontal and vertical. Okay,
Sir,
so be careful.
excuse me, sir.
Yeah,
For
go
line
ahead.
B, it says if dy by dt equals 0 and dx by dt, shouldn't it be not equal to 0? Then C has a horizontal tangent at dA equals A.
Pardon?
Shouldn't it be dx by dt not equal to 0?
No,
Why?
it's a dx dt, because if you guys get, for example, 1 over 0,
Yeah.
it's gonna be
Okay.
infinity. It's gonna be infinity, right?
Okay. Yeah.
Yeah. So it means when the denominator is 0 and the numerator is not 0. That's what I have here.
Yeah, but for a horizontal tangent,
Yeah, it's gonna be the reverse way.
yeah, that's what I'm saying. So for this line B, if dy by dt equals 0, so you form dy by dx by dividing dy by dt by dx by dt, yeah?
Yeah.
Okay, so 0 by 0 is infinity.
Now,
Then?
to get infinity, the top should be a number not equal to 0, as I mentioned here.
Oh, okay.
If you have 0 over 0,
Yeah.
it's indeterminate form. So we
Yeah.
did it in the
Yeah.
first chapter.
Okay.
Yeah. So for 0 over 0, you cannot conclude. That's why you have to approximate by using the limit.
Oh, right. Okay. We
Okay.
use an approximation.
Exactly.
Okay, and
Approximate it by using the limit. What
that's
I'm doing
for
here, is the third case in
okay.
C. Yeah.
Okay. 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 Thank you.
You're welcome. So what I did is, for this case, to get vertical tangent, I just prove why we have to use these two conditions. That's what I did previously. I told you to get a vertical tangent, the slope is equal to infinity for vertical line. And in order to get infinity, the denominator here should be 0 and the numerator not equal to 0. In that case, so for sure you will get infinity for your slope. Okay? And you have to keep in mind these two formulas. So you guys can see here, it is similar to the first one, but don't mix up, the two situations. Okay? So I've seen, past in past semesters, when you get question for vertical tangent, some students use the condition for horizontal, and for horizontal, they use the condition for vertical. So it means they don't know exactly, the difference between these conditions. So that's why I explain you, it's gonna be really easy to know which condition do you guys have to use when you understand the formula. Numerator 0, denominator not equal to 0, it means the whole thing is 0. And when it's equal to 0, it means your slope is 0 and you have horizontal line. Now, numerator not equal to 0, denominator 0, so you will get infinity. And as soon as you have infinity as your slope, it means the line is vertical. Now, what's going to happen now, when the two derivatives are both equal to 0 at A, again, you have to approximate it like what we did here, but it's going to be different different comparison. So again, you have to calculate the limit. But in this case, since you're looking for vertical tangent, you have to compare your approximation with infinity, not with 0. See, here's the reason why we compare our approximation with 0 is because we're looking for horizontal tangent. And for horizontal tangent, your slope should be 0. That's why we compare our approximation and 0. Now, when we're looking for vertical tangent, we have to compare our approximation and infinity. We approximate here, again, we approximate the slope. And as soon as the approximation is equal to infinity, we can conclude we have a vertical tangent. If this approximation now give us, something different to infinity, we don't have a vertical tangent. Okay, because this represents the approximation of the slope. It means the slope is going to infinity in that case. So it means you have horizontal tangent. If the slope is going to 0, you have vertical tangent. Now, if the slope is equal to a number, so it means, there is no horizontal or vertical tangent, at that point. Any question?
No, sir.
Okay, so your mic, please.
No, sir.
All right, thank you. So next, I'm going to give you one example. We're going to apply exactly what we explained in the previous one, the previous slide. So here we consider this curve defined by these two parametric equations, and the parameter is t. Okay, and this is what I call at the beginning. My x is equal to f of t, and this is my function g of t, the function y with respect to t. So the first question here is to find the point, the coordinates. Keep in mind this. We're not looking for the values of t. We're looking for more than the values of t. We're looking for the point on the curve where the tangent is horizontal. And we have to use, in this case, what I said about this horizontal tangent. Okay, we have to use A or B or both of them depending on what we will get. Okay. All right, so now let's see how to solve this one for the horizontal. Hello,
Wait, no, अपना vertical tangent.
Abdullah Al Mamun, your mic, please. Thank you. All right, so let's see the first example. All right, so here are our functions, x in terms of t and y in terms of t. And as I mentioned before, we're looking for the point where the tangent is horizontal. And based on our remark, when we use the conditions for horizontal tangents, as I mentioned, the numerator dy dt should be 0 and dx dt not equal to 0. So since at this point, I don't know the values of a in my formula here, I don't know the values of a. I don't know the values of a that is given here. In order to get horizontal tangent at a, these two conditions should be satisfied. So since I don't know a, I have to solve this equation. I solve for t in order to find all values of t satisfying this first condition. That's going to be always my first step. Find all values of t. It means finding all a's satisfying the first condition. As soon as you get them, you test if they satisfy the second condition. If yes, you have horizontal tangent. Okay? First step, you solve this equation in order to get the candidates A, and you test all candidates if they satisfy the second condition. If they satisfy the second condition, so it means you can you conclude you have a horizontal tangent. If the second condition is unsatisfied, it means you have 0 and 0. In that case, you have to use the approximation. But before using the approximation, you need to get these two conditions. Otherwise, it means this condition is satisfied and you conclude. If the second condition is unsatisfied, you go to B in order to be able to conclude. Okay? So you have to follow this procedure anytime you guys have such question. And that's exactly what I'm doing here. I'm going to solve this equation in order to find the candidates, the solutions. So this is the derivative of x with respect to t. So x is right here. When you calculate the derivative, it's going to be 3t squared minus 2t. And here's this 3 and 3 cancel out. That's why I got here t squared minus 2t. For the derivative of y with respect to t, you guys have to use chain rule to differentiate the first term. When you use chain rule, it's going to be et squared times the derivative of t squared, but derivative of t squared is going to be 2t here, minus you differentiate the second term. But the second term, just keep in mind, is e is a constant. So it means you have to differentiate t squared is going to be 2te, and you solve equal to 0, which is equal exactly this equation. I'm solving this equation in order to find the candidates, means all values of a satisfying the first condition. So when you solve this equation, you guys realize here you have a common factor, which is equal to 2t. So you take it out, it's going to be 2t bracket e to the power t squared minus e. And this product is equal to 0 if and only if one of the factor is 0. So that's why we have the first factor is equal to 0, or the second factor, the bracket here, is equal to 0. And the first factor equal to 0 if t is 0, So second factor equal to 0 if and only if the first term and the second term have the same exponent, because the base is the same. So here the exponent is t squared, here the exponent is 1. If t squared equal to 1, I'll get 0. That's why I said here t squared equal to 1. And t squared equal to 1 means t is equal to plus or negative 1. And you guys realize you have 3 candidates now. So next step, I have to test all these 3 candidates. So these 3 candidates satisfy, this condition here, because they are solution of this equation. That's why they satisfy this condition. Now I have to test if they satisfy, the second condition. If yes, I have a horizontal tangent. If not, I have to approximate. Yeah. How to get this? This part? Or is this is a derivative. It's a dy dt. Y is here. I use chain rule to calculate this derivative. So just gonna remind you what you did in. Is it okay? Oh, okay, sounds good. So I just use chain rule to differentiate et squared, and by chain rule is going to be et squared times derivative of t squared, which is equal to 2t. Now you differentiate the second part, is going to be 2t, that's what I have here, times e, because e is just a constant. Okay? So next step, I'm going to test these 3 candidates if they satisfy, the second condition. If yes, it means I have horizontal tangent. If not, it means I cannot conclude. I have to use the limit in order to be able to approximate my slope. Okay, and I'm going to compare my approximation and 0 because I'm looking for horizontal tangent. Okay, that's why I have to compare my approximation and 0. All right, so let's test 1 or negative 1. We're going to test negative 1 first. And for negative 1, I'm going to calculate dx dt when t equal to negative 1. Negative 1 is my first candidate. And here is, the equation of dx dt. So back to the next slide, you guys can see, to the previous slide, sorry, you can see dx dt is here. When you differentiate x, you will get t squared minus 2t. Now at 1, I'm going to substitute t by 1. Okay. So here it's at negative 1. I'm going to substitute, Okay. So here I substitute t by negative 1. Just keep in mind dx dt, based on what we did in the previous slide, is equal to t squared minus 2t. I just substitute here t by minus 1 and here by negative 1. And after calculation, you guys get 3. So it means the second condition is satisfied. That's why, I highlighted here, because it's not equal to 0. Because this helped me, give us the right to conclude here. The second condition is satisfied because the derivative of x with respect to t at t equal to minus 1 is not 0. It means the second condition is satisfied at 0, at minus 1, sorry. So I can conclude C has a horizontal tangent HT for horizontal tangent when t equal to negative 1. But the question did not ask me to find the values of t where, we have a horizontal tangent. The question was to find the point, the coordinates. So quite easy. As soon as I get the value of t, it's going to be really easy to get, the corresponding point. And to do so, we apply exactly what I did at the beginning of the class. So back to our initial function, you substitute here t by its value. Just keep in mind t equal to negative 1 here. When you substitute t by negative 1, you will get here negative 1 by 3 minus 1 going to be negative 4 by 3. So here when you substitute t by negative 1, you will get e minus e is going to be 0. And that's exactly what I got here. So the x coordinate is equal to -4/3, and the y coordinate is equal to 0. And these coordinates are obtained from the equations of x and y given by the problem, the question. Okay, you substitute t by -1 that you obtain from our calculation. Second test, we're gonna test the second candidate, which is equal to 1. At 1, same test. So we check if the second condition is satisfied. And back to our previous slide, I'm talking about, this second condition here. This one is already satisfied, by solving the equation. Now we have to check if all these 3 solutions satisfy, the second condition.
Sir.
Yeah.
When you substitute -1 to e to the power t squared, is the -1 in brackets? Does it get like squared and the negative effect like cancels off? Like
So
if it's,
here,
yeah, e to the power t squared, that's -1, yeah.
yeah,
So
it's a
when it's
-1. Yeah, you square it, becomes 1.
Okay, thank you.
Okay.
Yeah, thank you.
Because you substitute, the t by
Okay.
-1, and the square is applied to t.
Okay.
So as soon as t is -1, so you apply to -1, not to 1
Okay.
only.
Thank you, sir.
You're welcome. All right, so again here, yeah. Okay, so since I got, the value of t where the tangent is horizontal, now knowing the value of t, it's quite easy to get the corresponding point. I told you when you guys want to get a corresponding, each value of t correspond to a point. So what I did here is just, use the equation here. This represents, as I told you at the beginning of the class, the position on the curve. Each value of t give you 1 point on the curve. Okay, so when you substitute t by -1, you will get -1 to the power 3 is going to be -1 times this is going to be -1 to the -1/3, and minus, so -1 you square it, it becomes 1. So here it becomes -1/3 minus 1. That's why we got -4/3. Is it okay? And here when you substitute now by -1, you will get e to the power 1. You substitute here by -1, it becomes only 1. So finally, you just get e minus e. That's why we got 0. Is it okay? All right. Now we're gonna test the one again, dx dt, same formula. So we just substitute here t by 1 because we're testing 1. Just the equation of dx dt is right here. That's what I'm using. This is dx dt. I'm gonna substitute this by 1 and here by 1. I'll get here 1 minus 2, which is equal to -1. And that's what I got here. So since -1 is not equal to 0, again, the second condition is satisfied. I can conclude I have a horizontal tangent for ht, horizontal tangent, when t equal to 1. And that is at the point, again, we just want to find the point corresponding to t equal, the parameter t equal to 1. Again, you replace t by 1 in the equation of x and y's given by the question. When you replace here by 1, you guys will get 1/3 minus 1. And 1/3 minus 1 is going to be -2/3. And here you substitute t by 1 is going to be just e minus e, 0 again. So that's why we got -2/3 and 0. Any question?
Yes, sir. For the equations we're testing, so could you go back to the other slide? So for the 2t, we don't have to check since it gives us 0 from here, so we don't have to test anything.
For this one?
Yeah.
Yeah, I'll do it after. I
Okay.
just start with -1, and after I did 1. So
Yeah.
next I'm gonna do 0. I'm gonna test 0.
Oh.
Yeah, so we have to test all of them, all candidates. Sounds good?
Yeah.
All right. So next I'm gonna test, 0. Okay. But if I test 0, dx dt, you guys can see you substitute t by 0. So this is my dx dt. When you replace t by 0, your dx dt becomes 0. Okay, it means we have the situation at 0 dy dt is 0, and at 0 dx dt is 0. It means we have, the second situation. That's exactly what we have in this case. We have B. At 0, dy dt is 0, and dx dt is 0. In our case, A is 0. I'm testing t equal to 0. And this is what I got. And as I told you, when you guys have this situation, so you need to approximate because you cannot conclude. You don't know exactly if the tangent at this point is horizontal or vertical. What you do know is when you try to calculate, the slope at this point, you're not able to conclude because at the point, the numerator and the denominator of your slope are both equal to 0. And you cannot conclude. That's why you need to approximate. And that's exactly what I did here. You guys can see when you substitute here t by 0, you will get 0 squared minus 2 times 0 going to be 0. And that's what I mentioned here. My dx dt at t equal to 0 returns us 0. So in this case, we need to calculate the limit. And calculating the limit means we need to approximate the slope when t is really close to 0, because at 0 we cannot conclude. We don't know exactly what is the value of 0 over 0. That's why we need to approximate it. And we approximate, the slope here, dy dt over dx dt when t is close to 0, because we're testing 0. We're not testing another number. If it was 5, so we have to calculate the limit when t is approaching to 5. If you look at, in the slide, I just call it A. In our example, A is 0. Now, when you calculate the limit, and it's a numerator, you substitute dy by dt by its value that you calculate, on the first page. Dx dt is also calculating, on the first page. And when you substitute t by 0, you guys will get 0 over 0 on determinate form. And it means you can use chain rule. Sorry, but not chain rule. You can use, the L'Hopital's rule, but I don't want to use it because I don't want to make it complicated. So I realize here I have a common factor which is equal to 2t. It's going to be easier to take it out. When you take it out here, you will get 2t times e to the power t squared minus e. When you put it back, you guys will get here the numerator. And from the denominator, I'm going to take a t out. Okay, so I'll get, t times t minus 2. And the t cancel out. Numerator now becomes 2 times et squared minus e, and the denominator is equal to t minus 2. Now, when you let t approaching to 0, the numerator you substitute here t by 0, you will get e to the power 0, which is equal to 1. The second term is a constant, doesn't depend on t. And the denominator, when you substitute t by 0, it becomes a minus 2. So you realize here, when we approximate the slope, we got a number which is not 0, because this number is not 0. Okay? 1 minus e, just keep in mind, e is approximately equal to 2.7. So you have here inside the bracket 1 minus 2.7. Okay, it's not 0. So it means the approximation gave us a number which is not 0. The reason why I compare my approximation and 0 is I'm looking for horizontal tangent. That's why I have to approximate I have to compare the approximation of the slope and 0. So what we can say here is when we approximate the slope at 0, we'll get this number, which is not 0. It means we don't have horizontal tangent at this point. And there is no need to find the corresponding point because the question asks us to find the point, the coordinate where the tangent is horizontal. Here the tangent is not horizontal. I don't need to specify the coordinates. Okay, I just conclude we don't have horizontal tangent because of what I notice here. You guys have to use not equal to 0. Not equal to 0. My approximation is not 0. That's why I can conclude. If not equal to 0 is missing, you will not get full mark. You can deduct 0.5, for example. So be careful, because this gives you the right to conclude. This is the reason why you can say the tangent is not horizontal, because your approximation is not 0. Okay, that's what I said here. To be able to conclude, you have a horizontal tangent, your approximation should be equal to 0. And you guys can see here our approximation is not 0. It means there is no horizontal tangent. Any question?
So when we get the indeterminate form, can we still use the L'Hospital's rule and it will get the same answer?
Yeah. I don't use it because here, if I want to use L'Hospital rules, I have to differentiate here by using product rule. It's going to make it a little bit longer. Just want to save time. Okay, because here you have a product of two functions, you have to use product rule. So here it's easy. The derivative is going to be just 2e. But here you have to use the product rule. And here the derivative is also 2e. It's going to be just 2t minus 2. Is it okay?
Yes, it is. Thank you.
Welcome.
Sir,
Yeah.
how about t square minus 2t different 0? Do you need to find t different number? In previous picture, the picture before.
This one?
No. The picture before. T square minus 2t different 0. You don't need to find the value of t different.
So here?
Up to t
Pardon?
square. T square minus 2t
Where is
different
it?
0.
So here?
Yes. You
No,
don't need to
because this
find
is not an equation. This is just something that you guys can use to test. You cannot try to trace it. Okay, this means this is not equal to 0, blah blah blah. This is your equation. Equation means you have mathematical expression equal to another mathematical expression or equal to a number. So here you don't have equal. So it means it's not an equation. You cannot try to say, okay, this means not equal, not equal. You have to solve this and you find all solutions. And for each of them, you have to test by use. This is just for testing your solution obtained from this condition. Okay?
Okay. Yeah. If we find t equal 2 or 0, we can use it to cancel it by the first.
Yeah, if for example you solve this one and get, you say 0.
Yes.
Yes, so that's what I got here.
And we cancel it before 0 minus 0 equal 0 different 0. Yes.
Yeah, it's equal to 0. That's why if equal to 0, that's why we did this. That's what I told you. That's what I got here. That you what you're saying.
Yeah, I see.
0 minus 0 is 0. That's why we cannot conclude and we have to approximate.
Yes. Yes.
You getting me?
Yes, I got it.
Yeah, we have this situation. You see, both of them are equal to 0.
Thank you.
Yeah, both of them are equal to 0. We cannot conclude, as I said, you have 0 minus 0. So that's why you approximate by using limit. But if you don't have this situation, you don't have to do this. You will get, one of these two situations. You have only this one or this one. This is the second situation. So if this one is satisfied, you have a horizontal asymptote. If not, it means you have this situation. And in this case, you have to approximate. If your approximation gives you 0, you have horizontal. If your approximation gives you something different to 0, you don't have horizontal asymptote. Because here it means you're approximating the slope. And when the approximation gives you 0, it means my slope is almost equal to 0. And I can take it as 0. So in this case, and I'll get, horizontal tangent in this case. And that's exactly what we did. And when we approximate on that case, so we got here a slope which is not equal to 0. So that's why we don't have horizontal tangent, because the slope is a number not equal to 0. Is it okay?
Okay.
All right, so now let's see the second question. Question number 2, yeah. Oh, you want to take a break? Yeah, I was just planning to let you go earlier. Okay, so we will be done in about maybe 15 or about 10 minutes. Okay, I'm just gonna solve the second questions, and if you don't have any question, I'll take the attendance before letting you go. Sounds good? Is it okay for you?
Yeah, it is.
All right.
Yeah, it's
All right, so for the second question, yeah, so for sure, if the class gonna take 2 hours, like what we're supposed to be, I'm gonna give you a break after 1 hour, so we can take like 10 minutes after 1 hour. But today, I don't have too much to cover, so that's why I'm gonna let you go earlier. Okay. So I have just one more question, and then you guys can ask your questions before I take the attendance. All right, so for the second question, now we're looking for the point where the tangent is vertical. It's a little bit similar to the first one, except here we're looking for vertical tangent. So we have to switch our two conditions, as I mentioned before. All right. So to get a vertical tangent line, as I mentioned before, the denominator dx dt should be 0, and the numerator dy by dt not equal to 0, because if we have any number not equal to 0 over 0, you will get infinity. And if the slope is infinity, the line is vertical. Now, as I told you, you solve this time you solve with dx dt. In the first time we solve with dy dt. So now we solve with dx dt. And when you solve dx dt, so you get some solutions if there is any, and then you have to test your solution here if the solution satisfies this condition. So yeah.
So do we use the one that is meant to be equal to 0? Like for the horizontal tangent, we used for the y dt.
Yeah.
Okay.
For horizontal, you solve dy dt, and you will use dx dt to test. For vertical, you solve dx dt, and you use your dy dt to test your solution.
All right, thank you.
Okay. Okay. All right. So now dx dt based on the previous slide here, when you differentiate x with respect to t, this is what we got from the first page. Is going to be t squared minus 2t equal to 0, and we took here t out, going to be t times t minus 2, and this solution is when t equal to 0 or the bracket equal to 0, and bracket equal to 0 going to give us t equal to 2. So here we have two candidates. Again, we have to test both of them. I'm going to start 0 because 0 we already tested this one, and based on what we did before, we know at t equal to 0 this condition will not be satisfied because we got it previously. Okay, if this condition is not satisfied at 0, it means both of them are equal to 0, and in that case you need to approximate. But the approximation, we don't need to do it again because we did it before. We don't spend a lot of time on it. Okay, so based on our approximation that we did in the previous page, so since you have this condition based on what we did before, that's why we have to approximate by using the limit. But the approximation, we did it before. That's what we got here. I just copy what we did here. Without copying all this step, we don't need to copy again all this step. We already did the work, so we don't need to. So the work is already done now. We don't need to repeat again. So what we have just to remind here, the approximation is equal to this value. That's what I did. Since I have 0, second condition unsatisfied, that's why I approximate my slope. And based on what I did previously, this is the approximate value. But now we have to compare our approximation with infinity, not with 0, because we're looking for vertical tangent. And for vertical tangent, the slope should be equal to infinity, or its approximation is close to infinity. So here its approximation is not close to infinity. It's a number. That's why we can conclude we don't have a vertical tangent at 0. So it means at 0, we have neither vertical tangent nor horizontal tangent. That's the meaning, because based on one we did before, there is no horizontal tangent. And again, here, there is no vertical tangent. So next, we will test the second solution here. Okay, I'll let you write down this, and in the next page, we'll test now too, the second candidate. So let me know whenever you're done. You okay?
Yes.
Yes, sir.
All right. Now we're gonna test the second value here too. All right, so we're gonna test 2 again. When t equal to 2, we have to calculate dy dt at t equal to 2. And when we substitute t by 2 in the equation of dy dt, so you guys will get 4e to the power t squared, because here t is equal to 2. If you look at the formula of dy dt from the first page, so we have 4, so we have 2t e to the power t squared, but when we substitute t by 2, the 2t becomes 4, and here we'll get the t squared becomes 2 squared. So here it was 2TE, the 2T becomes 4E. And after calculation, you guys get this. And you notice now the second condition is satisfied. The dy dt is not equal to 0. So since the dy dt at 2 is not 0, we can conclude, C has a vertical tangent when t equal to 2. And this corresponds to this point. And how to get this point? Again, as I told you, you guys have to use the formula of x and y when you substitute t by 2. In the equation of x, when you substitute t by 2, you will get -4 by 3. And in the equation of y, you substitute t by 2. So you guys will get here e to the power 4 minus 4e. So these two values, as I mentioned, are obtained from here. When you substitute here by 2, you will get 8/3 minus 4. And after calculations, you will get -4/3. So here, when you substitute t by 2, is going to be e to the power 4 minus 4e. And that's exactly what we got. And we're done. Any question? So you guys have any question?
No, it's okay.
Yeah. All right, so that's all for today. I'm gonna take the attendance before letting go.